All right, so today we're talking about Unit 9, Lesson 5, and we're talking about expanding and condensing log expressions. So our objectives are going to be expand and condense the log expression using the properties of log. Okay, so expanding and condensing means you make it longer, you make it shorter, you know. So here's a little quick review. Let's go through this. Try to pay attention to this because this is going to help you make sense of the rest of the lesson. Okay. So here is, our just a generic log equation. So log base b of a is equal to n. And, in exponential form, it's b to the n equals a. Basically, a log expression is basically asking what power of b gives you a. Okay. So this is the exponential form. So I have one here. I have log base 3 of 9 is equal to n. When you first look at this, you're like, what is n? What is it even asking? What is log? Right? So you got to think about this. Maybe in exponential form, it would make more sense. Basically, it's asking what power of 3 gives you 9, and then that is a little bit clearer to see, right? That n has to be 2 because 3 squared is 9. All right, and here's another one. Here's log base 3 of 27 is equal to m. Maybe you're a little bit better at this now because you've seen it a couple times. It's like 3 to the m is equal to 27. Then m has to be equal to 3. Okay, all that is nice and good. Let's get into it then. Now I have if log base 3 of some number that is 9 times 27. Okay, what's that? Log base 3 of that whole number, 9 times 27. I don't know what that is, right? But it's a big number. But I know it's 9 times 27. So let's break this down. It's asking you 3 to the what gives you 9 times 27, right? 3 to the something gives you 9 times 27. Well, I changed the bases to make them look the same. It's all base 3 now because I did 9 earlier. I did 27 earlier. I know it's 3 squared and 3 cubed. And now since they're the same bases, we can add them together, right? Add the exponents, right? So really the exponents on the left side here is equal to 2 plus 3, which is 5, right? So log base 3 of 9 times 27 is 2 plus 3. Right? So you want to know why it's adding. It's because log is talking about the exponents. And when you have exponents of things that are multiplied together, if they're the same base, because base is 3, you add the exponents. Right? So that's where the adding is coming from. So here I have log base 3 of that. It's from log base 3 of 9 adding to log base 3 of 27. Okay? So that's where I got the 2 and the 3 from. All right, so let's do a couple more. See if you guys can keep that in mind, okay? I got log base 3 of 9 times 27 is the log base 3 of 9 plus the log base 3 of 27. Because each of these is just the exponents of 3. And when you multiply them, you add the exponents. Okay, so here's log base 3 of 729. Well, that's a monstrous number, right? We don't know what 729 is. Not friendly at all. It's really hard to do. But what if I tell you 729 is just 27 times 27? Okay, so now I got log base 3 of this number times that number. That means that I can do log base 23 of 27 plus log base 3 of 27. All right, same rule here. You just add them because you got things that are multiplied together in here. Okay, and that's just 3 plus 3, which is 6. All right, another one I got log base 3 of 4 times 16. And that is just log base 2 of 4 plus log base 2 of 16, which is now 2 and 4 gives you 6. See, nice and easy now. And now I hope it's starting to click with you guys here. All right. So based on that, we can write down the different properties of log, and that's going to help us with the problems that we're doing today. Okay. So the first one is the one that we just talked about, which is called the product property, which means that if you have log base b of x times y, okay, log base b of x times y, you have log base b of x plus log base b of y. Again, you're adding because you're adding the exponents. These are just exponents of b. Okay, so you're adding them. An example of that would be log base 10 of 5x, which is log base 10 of 5 plus log base 10 of x. Okay, the next property is really similar. This is the quotient property, which is when you have log base b of some things that are divided by each other, right? So x divided by y. So remember, when you divide things of the same base, you subtract the exponent. So that's what I'm doing. Log base b of x, which is the exponent of b that gives you x, and the exponent of b that gives you y, you subtract them. Okay? So I have log base 10 of 5 over x is log base 10 of 5 minus log base 10 of x. You really want to write these down, okay? These in your notes here. We're going to use them all the time. And the last one, the power property. Okay, so I have log base b of x to the y. Okay, remember, this is like when I keep on saying the exponent on exponent, right? Then you multiply them. That's what I'm saying. I'm doing y times log base b of x. Okay, because log base b of x is the exponent of b that gives you x to the y. So that's why you're taking y and you times that whole log base b of x. All right, so here you have log base 10. By the way, I've been writing log base 10, but it should have been log base b this whole time. Oh, Jesus. All these should have been log base b. Oh, wait, no, this is right. What I've meant to do for these examples, oh man, I'm losing it. Log base 10 is because I want to remind you guys that we rarely ever see log base 10 written out, because that's one of the shorthand log, right? If we don't write it, the base is log base 10. I'm writing this out here to see if you guys notice that, oh, this is kind of weird. We never see log base 10, right? So what we should have done is not write the base 10 at all. I typically, you would just write log with no base, and that would mean log base 10. But you could write out log base 10, and it means the same thing. Okay, but anyways, the rule here is log base 10 of x to the fifth is equal to 5 times log base 10 of x. And then let's apply these rules, okay? We're going to expand these. So log base 3 of 5a. Okay, these things are multiplied together. So that means that you split into things that are added, right? So I have log base 3 of 5 plus log base 3 of x. Okay, because these two things are multiplied together. I have log with no base now. You see, this is what I'm talking about. If there's no base, it means that the base is 10, right? Just like earlier on all the examples I wrote 10, you really don't write the 10. And it's assumed that it's a 10. So log of 2 over x, basically log base 10 of 2 over x, is equal to log of 2 minus log x. Okay? So one thing you really want to remember is anything at the bottom here, you're subtracting it because the exponent is negative. And here, this is the exponent of it, you know. So if it's at the bottom, exponent is negative. So here I have log base 2. I mean log 2 minus log x. Okay, here I have ln x to the third power, x cubed, right? Ln, what is ln? Right? I could have written log base e, but I write ln. Same thing, right? But we don't really write log base e, we write ln. But if you write log base e, it means the same thing. Okay, so here the rule is, this is the product property. You bring the 3 to the front, so I have 3 times ln x. This means times. Okay. Here I have log of x plus 5. What does this mean? What can I do? Right? A lot of people get this confused with the top example here. Like, is it x times 5, x plus 5, log 5 plus log x? This is not log x plus log 5. Okay? Because that would be log 5x. This, there's nothing you can do about this. Okay? You can't expand this. All right? You can only do that if it's multiplying in here. All right, now here, let's do one that's more complex. I have 2 times x cubed. Now, typically the rule of thumb when you're doing this, when you're expanding, is that you do product or quotient rule property before you do the power property. Okay, split them out first before you do the exponent. So here's multiplication. I split this out into log 2 plus log x cubed. And here, log 2 is basically done, right? But log x cubed, I can still use the power property, bring the 3 to the front. So I have log 2 plus 3 times log x. Okay, again, product and quotient property first before power property. By the way, a lot of people make the mistake of dropping the 3 here, dropping the 3 to the front, which is log 3 log 2x. Now, this doesn't work because the 3 is not the exponent of the 2. It's only the exponent of the x. So that's why it's only 3 times log x. And there's no 3 in front of the log 2. The 2, the exponent is 1. There's like a 1 here. Okay. Here's something more complex, but follow this rule and you'll be fine. Like product and quotient before you do the power property. Okay. So I split this out. ln of 2, ln of a squared. Right. They're both on top, so they're both positive. And then ln of b to the 7 is negative because it's at the bottom. And then you do the power property. Bring the 2 to the front, the 7 to the front. So I got ln of 2 plus 2 ln a minus 7 ln b. Got another one here. Log base 5 of x, square root of x. Right, so this one, square root of x, really the exponent is 1/2. Right, so I rewrite that as x to the 1/2. And then I use the power property. 1/2 goes to the front. I got 1/2 log base 5 of x. That's it. Next one, I got log base 4 of 5 a to the 4th, b, c to the 6th. It looks all crazy, but it's all the same thing, you know. Product and quotient first, so split them out before you do exponent. Split them out. I got log 5, right? Log base 4 of 5 plus log base 4 of a to the 4th plus log 4 of base 4 of b plus log base 4 of c to the 6th. And then do the power property of each of them. So this one's done. This one, bring the 4 down to the front. B is done. C, you bring the 6 to the front. And there we are. Okay. Now we're going to do some condensing, which is going backward, right? So going backward, usually you do the power property before the product and quotient, right? Just like you wrap a present, and then now you unwrap the present. You got to do the opposite way, right? So you go the outer layer first, so you do power before product or quotient. For example, here I got log of 8 minus log of 4. There's no exponent involved, so I'm good. So I'm just going to put these together. This is subtract. This is positive. Positive goes on top. Negative goes at the bottom. So I have log of 8 on top, 4 at the bottom. Okay. One more time. Because the log of 4 is negative, when you condense it, the 4 is at the bottom. And the 8 is positive, so the 8 is on top. And that gives you log of 2, basically. 8 over 4 is 2. Okay. Now this one here, there's an exponent involved. Okay, so I do the power property first, which gives me log base 3 of x to the 7th plus log base 3 of 13. Now I do the product property. So I put these together. I have log base 3 of 13 x to the 7th. All right, here, more crazy stuff. But they're all adding, so they all go on top. Nothing goes to the bottom, right? So just move the exponent to the back first. Move the exponent on. Move the exponent on. Move the exponent on. So I get log base 2 of x cubed plus log base 2 of y to the sixth plus log base 4 of z to the fourth. Okay? Power property first when you're condensing. Okay? Now you put them together. These are adding, so you put them together. So I have log base 2 of x cubed y to the sixth plus log base 4 of z to the fourth. Now, why didn't I put the z to the fourth together in here? Right? Does anyone see why? Right? Shouldn't it be log base 2 of x cubed y to the sixth z to the fourth all in one? No. And the reason being is that z to the fourth is base 4. Right? You can't combine them if they're not the same base. Just like when you're expanding them, you keep the same base. Now they're different bases. You can't combine them. So this is as far as you can go, okay? So when you do these, be very careful. They're going to sneak in one with a different base, and you put them all together. It's going to be wrong, right? So we cannot combine log base 2 and log base 4.